Two terms in an arithmetic sequence are -4 is term 4 and term 7 is 23. What is term 1? So what we're going to do is we're going to just sort of draw a diagram of what's happening here. I don't know term 1. I don't know term 2. I don't know term 3. I know that term 4 is -4. Then I don't know term 5. I don't know term 6. And I don't know term 7. Oh, I do know term 7, sorry. Term 7 is 23. I'm going to show you two techniques for solving for this. And then you can decide which one you think you would think of or you would like to use if you were doing this on a test. Okay? So we're going to call this method 1. And method 1 says that if I started here, I would have to add whatever d is to get to the next one. And then I would add d again to get to the next one. And then I would add d again and get to 23. So using that as a visual, I could write an equation. I could write an equation saying that if I had -4 and I added d 3 times, it's going to equal 23. Does that logic make sense? Because they told me it's an arithmetic sequence, I know there's that d value that you add every single time. And because I drew a picture, I'm like, oh, so if I start with -4 and I add d 1, 2, 3 times, I'm going to get to 23. And what this equation lets us do is the equation lets us solve for d. Because I can add 4 to both sides. Then I have 3d is equal to 27. I can divide both sides by 3 and then get d is equal to 9. Once I have d is equal to 9, I could either subtract 9 3 times until I get back to my first answer, or now I might actually want to use my formula. So going to my formula sheet, I know my formula sheet, and I'll just write it out. And there's some things we could plug in. Okay? I could plug in 9 for d. And then I could plug in either -4 or 23. If I plug in -4, which term is that one? That's term 4. If I plug in -4, then I'd have to plug in 4 for n. If I chose to plug in 23, does it make sense that my n would have to be 7 then? It doesn't matter which one you plug in. What results is an equation where the only thing you don't know is term 1. So now you can use your algebra skills to get term 1 by itself. So order of operations, 4 minus 1 is 3. 3 times 9, I would get -4 is term 1 plus 27. And I could subtract 27 on both sides and get -33 for term 1. No, -31. See? -31 for term 1. I mean, you could have got that by going -9, this would be -13. -9, -22. -9, -31. The reason I wanted to show you with the formula is because subtracting 9 3 times doesn't take very long. But I could give you this same question where instead of term 4, it was term 41 and term 44. And then you wouldn't want to subtract 9 40 times to get back to the beginning. You would want something more efficient. Method 2. Okay? Method 2 uses your formula more, and in method 2, temporarily make term 4 term 1. And temporarily make term 7 then term 4. What we're basically doing is we're saying I'm going to ignore that there was 3 numbers to start off with. I'm going to think this is term 1, term 2 I don't know, term 3 I don't know, and this is term 4. Because that lets me use my formula right away to find D. I can go to my formula and say, I'll write out the formula first, and say, I know term 1 is -4. I know term 4 was 23. So I can plug things into my formula as if this was term 1 and this is term 4. And you'll notice you get the same as the pattern we talked about. But we got that pattern in a different way. And from here, you would also get D is 9. And once you get D is 9, you would continue just like we did in method 1. So we have 2 different methods for finding what D is. One, we're looking at a pattern. Hey, I'm at -4. If I added D 3 times, I'd get to 23. That helps me find D. But if I like using formulas more, I could temporarily think of this as term 1 and this is term 4, find out what D is, and then go back to the actual one and find out what term 1 is. So we're really going to work a lot with formulas on this one. I'm going to get you to circle questions 10 and 13.